Hi everyone, in today's lesson we're going to talk about how to complete the square when a is greater than 1. But before we can do that, let's just recall how we would complete the square with a equal to 1. So what I'm going to do right now is do this example with you, and then I'd like you to try this one on your own. So if you remember correctly, the first step in completing the square is always to get the equation equal to 0. So I'm going to begin by adding the 97 on both sides. So I get x squared plus 14x plus 97 equals 0. Alright, next, I want to try to create a perfect square trinomial, because right now if I take half of b, which is 7, and square it, this should be 49 for it to be a perfect square. So what we're going to do is we're going to create that perfect square trinomial by adding that number and then subtracting that number and then bringing down the 97. So the work on the side would be half of 14, so 14 divided by 2 squared. So 7 squared, which is 49. So that's the number that I'm going to add and then subtract. Then I'm going to factor this perfect square trinomial into 2 factors of x plus 7. And we know that x plus 7 times x plus 7 is the same thing as saying x plus 7 squared. And remember, this step here is the trick. Because it's a positive 7, it's always half. Half of 14 will go here and here, so it would just be x plus 7 squared. Next, we were going to combine the like terms here. We're going to take negative 49 and add 97. And you get 48. And now we're going to solve. So the goal is to get this x by itself. So we're going to subtract this 48. So x plus 7 squared equals negative 48. I just subtracted it without showing the work. And in order to get rid of the square, we have to do something that's opposite of squaring, which is square rooting. So the square and the square root will cancel each other out. We'll be left with x plus 7 equals plus or minus. And now we know that we have a negative, so we have to pop out that negative. And at the same time, we can break up 48 into 16 and 3. So really this would be 4i radical 3. I got the 4 from taking the square root of 16, and I got the I because I pulled out the I here. And then the last step would be to subtract 7. And the final answer would be x equals negative 7 plus or minus 4i radical 3. Alright, what I'd like you to do now is try this example, and I will check for homework. So write homework, okay? You have to finish that one. Alright, now what I'd like to do is move on to completing the square when the a value is greater than 1. Alright, so the first step is still the same. We're going to set the equation equal to 0. So we have 2x squared plus 16x and then minus 8 equals 0. All I'm doing here is just subtracting 8. Now, the part that's different is that the x squared must have a coefficient of 1. Right now, the x squared has a coefficient of 2. So what we're going to do is we're going to take out the leading coefficient, take out this 2, out of the x terms only. So we're going to focus our attention just on these two terms. I'm going to take out this leading coefficient of 2. And we'll be left with x squared plus 8x. Now, bring down the minus 8 and equal 0. And now we're still going to complete the square, except now the trinomial that you're speaking about is inside the parentheses. So this is your b. So we're going to take half of 8, which is 4, and then 4 squared, which is 16. So we have a 2 in front, x squared plus 8x. Now we're going to add 16, but be careful, we're actually going to have to subtract 32, then minus 8, and then equals 0. Now let me go over why we had to subtract 32. Because since there's a 2 in front here, I'm technically taking a 2 times x squared, that gives me my 2x squared. 2 times 8x, that gives me 16x. But 2 times 16 gives me 32. So I'm technically adding 32 to this equation, so now I have to subtract 32. So think of it as we're just drawing an arrow here, multiply, and that goes there. All right, now if we factor, knowing this is the trick, this perfect square trinomial can be written like that. I can take a negative 32 and a negative 8 and add those together and get negative 40 and have it equal to 0. And then we're going to solve. We're going to add the 40 on both sides. We have 2x plus 4 squared equals 40. Divide the 2. We have x plus 4 squared equals 20. And again, take the square root of both sides because the square and the square root cancel each other out. So we're left with x plus 4 equals, plus or minus, I'm going to break up the 20 while I'm here into the square root of 4, square root of 5, which becomes 2 radical 5. And then subtract the 4, and I have x equals negative 4 plus or minus 2 rad 5. Those are my roots. Alright, so I just want to recap the parts that were different than when the leading coefficient is 1. So we're still setting it equal to 0, except now we have to take out whatever the leading coefficient here is out of the first two terms. So we take out a 2, and we're left with x squared plus 8x. Now we're going to complete the square with this trinomial. We have an 8x here, so we have it and square it, and we get 16. So now this is my perfect square trinomial. But technically I'm taking a 2 times 16, which is 32, and then I have to subtract that. So we add it and subtract it, and then we're done. And the rest is pretty much the same. Alright, let's try another example. Alright, so what I'd like to do now is first set it equal to 0. So I'm going to subtract 6x on both sides. So I have 2x squared minus 6x plus 20 equals 0. Alright, now we see that the leading coefficient is not 1. So we have to take out the leading coefficients out of the first two terms. We'll be left with x squared minus 3x, and then we have the plus 20. Now we're going to complete the square. Half of b and square it. So negative 3 divided by 2 squared. Now I actually can't have negative 3 halves. It doesn't go in evenly. So we'll just square it, and it will become 9 over 4. So now we're going to complete the square by adding 9 over 4 here, and then subtracting some value, then adding 20, and setting it equal to 0. So the first question is, what goes here? We can't just put 9/4 because there's a 2 in front. So we're basically, remember, we're doing 2 times 9/4 and putting that here. So remember, 2 times 9 over 4. Put the 2 over 1, multiply straight across. 18 over 4. and I can divide the top and bottom by 2. So 9 over 2. All right, now we're going to factor this perfect square trinomial using this part here, the half part, as my trick. So it's 2x minus 3/2 squared. And then you're going to combine these two like terms, 20 and negative 9 over 2. You can use the calculator for that. Why don't you type that in and then hit pause and then hit resume when you're finished. Okay, you should have gotten 31 over 2. Positive 31 over 2 equals 0. All right, now we're going to solve. So we're going to subtract first. Minus 31 over 2. So 2x minus 3/2 squared equals negative 31 over 2. Divide both sides by 2. X minus 3 over 2 squared equals. All right, now you can type this into the calculator just the way you see it and hit resume when you're ready. All right, you should have gotten negative 31 over 4. Now again, we're going to take the square root of both sides because a square and a square root cancel each other out. And we are left with x minus 3/2 equals plus or minus I'm pulling out the negative, rad 31 over 4. All right. Now next, we could add the 3/2 to this side. So I'm just actually going to rewrite this over here so you can see where I'm going. So if I add 3/2, now, when I take the square root of a fraction, I'm taking the square root of the top and the square root of the bottom separately. So this means square root of 31 over square root of 4. So when I write my answer, I could say x equals 3/2 plus or minus I rad 31 over 2. Because I took the square root of 4 and made it 2. Now that's one way to write the answer, or since they have the same denominator, you could write it like this. Okay? So this is an acceptable answer, or this is an acceptable answer. So both are the same. Alright, I know I threw a lot at you, but I'd like you to see what you could do with these two examples down here. I'm going to check those that you've done them for homework. So I'm going to put homework here and homework here. If you don't do these two problems, then I can't give you credit for the homework at all. I just want to see that you've tried. Alright, jot down any questions that you might have, and we'll see you in class tomorrow. Have a good day.